this question, students. Now check. Now this question, what they have done, all the institutes, they have given one equation, vector equation, something like that. I will tell you one trick, very small trick. By this you can click it in 1 minute. Okay, see, obviously I will take more time to explain it. Now see what is happening. They are saying 2-point particles. This starts from here. Now there are point particle of mass m. Let's consider there is another point particle of mass m. Okay, they are rotating with how much? This is the position pi by 2. So this is the position they have given. Two particles are here. So they are at position pi by 2. Understood? And the other one is at position minus pi by 2. So that means right now they are here. Now they are doing what? They perform identical uniform angular speeds they are having. Got it? So that means, so if I consider radius is given, let's consider radius is r. So they will be moving with how much velocity here? Omega r. And this one will be moving with omega r. Now try to understand, if I take this direction as I cap, if I take this direction as minus I cap, if I take this direction as j cap, and if I take this direction as minus j cap. Okay, at this situation, if I try to find the net momentum, total linear momentum, what is the total linear momentum here in vector form? It will be omega r I cap plus omega r minus I cap. Understood? Omega r minus I cap. So answer will be what? 0. By common sense, you can get an idea. Two bodies moving with velocity mv minus mv, total is 0. Got it? Now when they are reaching here, it is having how much velocity? Omega r. When they are reaching here, its velocity is again how much? Omega r. Okay. In this case, now in this situation, when they are reaching here, what is the total momentum? Now try to understand, in this situation, omega r is in direction minus j. This omega r is also in direction of minus j. Understood? So they will become what? In this case, linear momentum will become what? mv minus j plus mv minus j. Try to understand, it will become maximum 2mv into minus j cap. And yes, v is nothing but omega r I am writing. Okay, so v is nothing, omega r you can put. So this is the maximum. Understood? So when they are reaching here, it's the maximum. When they will reach here, now from here and here it is again decreasing. Now here one is moving like this, other is moving like this. It's like same situation here. So again here total momentum will become what? 0. Now try to understand, in this situation it is 0, here it is becoming maximum, again it is becoming 0. By this way you can get an idea. Okay, for example, you are taking it here. Okay, you are taking it here at let's consider with the horizontal it is making some angle theta. So in that case, if velocity is v here, which is obviously your omega r, so it will be having one component here. How much? V sine theta. Other one will be reaching here, it will be having how much component here? V sine theta. Understood? So it means in the downward direction, momentum here is 0 right now. In negative j direction, momentum is increasing because v sine theta is less than v, right? Here it becomes v, maximum v. Then again it decreases here. Understood? So what is going to be the answer? Option number 1. 0 momentum, increase to the maximum, then again becoming 0 here. Here again the addition is 0, right? So this is how you can solve this question, right?